This is free response question 5 from the 2024 AP Calc BC exam. This is part of the no calculator section. The function f is twice differentiable for all x with f of 0 equal to 0. Values of f prime, the derivative of f, are given in the table for selected values of x, which we see here. Part A says for x at least 0, the function h is defined by h of x equals this integral here. Find the value of h prime of pi and show the work that leads to your answer. When we take the derivative of h to find h prime, by the fundamental theorem of calculus, this integral is going to go away, and we'll just be left with the integrand, and we'll have to plug in pi. And we can use the table to evaluate that. So here for part A, h prime of pi, that's just going to be the integrand in the definition of h, so the square root of 1 plus f prime of pi, we're plugging in t equals pi, squared. And what is this? Well, f prime of pi, we see from the table, is 6. So this is the square root of 1 plus 6 squared. So the square root of 1 plus 36, or the square root of 37. Now, part B. What information does the integral from 0 to pi of the square root of 1 plus f prime of x squared provide about the graph of f? You're supposed to recognize this as the arc length formula. Integrating the square root of 1 plus the derivative of a function squared gives us the length of the function, the arc length, from the lower bound of integration to the upper bound. So this is the length of the curve of f from 0 to pi. And there that is written out. The length of the curve f from 0 to pi, that's what that is. It's arc length. On to part C. Use Euler's method, starting at x equals 0, with two steps of equal size to approximate f of 2 pi. And show the computations that lead to your answer. Since we're using two steps of equal size, we will of course start at x equals 0, and then we'll jump forward pi, and then we'll jump forward another pi to get an approximation of f of 2 pi. So for Euler's method, we start by going from 0 to pi. We know from the problem that f of 0 is 0. And then we can approximate f of pi using the derivative of f at x equals 0. So let's write this out. What is f of pi? Well, it's going to be approximately f of 0 plus the rate of change, or the derivative, at 0, multiplied by the change in x when we go from 0 to pi. That change in x, of course, is just pi. The idea, of course, is that the derivative at x equals 0 tells us how much y should increase if we increase x. So this equals f of 0 we know is 0, and then f prime of 0 we know is 5 from the table. And then, of course, this is getting multiplied by pi. So if we increase x by pi, starting at x equals 0, the derivative tells us that y should increase by approximately 5 times that increase in x, so 5 pi. So our approximation for f of pi is just 0 plus 5 pi, which is 5 pi. And now we can do this process again to take another step forward and get an approximation of f of 2 pi. F of 2 pi is about f of pi plus the derivative of f at pi multiplied by the change in x. If we're going from pi to 2 pi, the change in x is just 2 pi minus pi, which of course is pi. So let's start to plug in some of this information. F of pi, we know from the first step, is about 5 pi. So this is about 5 pi. And then f prime of pi, we know from the table, is 6. So this is going to be plus 6 multiplied by 2 pi minus pi, which is pi. So f of 2 pi is about 5 pi plus 6 pi, which is 11 pi. Again, the idea is that the derivative at a point tells us roughly how much y should increase based on a small increase in x starting at that point. So we take that increase in x and multiply it by the derivative. That tells us how much we have to add to the starting position. And we repeat this as much as we want to get the approximation at the desired point. All right, on to part D. Find the integral of t plus 5 times cosine of t over 4 and show the work that leads to our answer. Here we have an algebraic function, t plus 5, times a transcendental function, cosine of t over 4, and that means it's a prime candidate for integration by parts. We'll let u equal t plus 5, so when we take the derivative and get du, we'll get a nice simple function. And we will let dv equal cosine of t over 4. We can integrate that and be no worse off. So for part D, this is our integral. Again, we're going to let u be t plus 5. That way, du is just dt. Very straightforward. And then dv is forced to be cosine of t over 4 dt. Then we can integrate this to get that v is equal to 4 multiplied by sine of t over 4. Now, we should just check real quick. When we use integration by parts, we have to integrate v du. Is that something we can integrate based on our choices here? Well, v is 4 sine of t over 4, du is dt, so yes, we could definitely integrate v du. This will be very easy. So applying the integration by parts formula, this will be uv, so t plus 5 multiplied by v, which is 4 sine of t over 4, uv minus the integral of v du, minus the integral of v du. So finishing up this evaluation, I'll go ahead and put the 4 first, just because I think that looks better. So 4 times t plus 5 multiplied by sine of t over 4. Then we just have to integrate 4 sine of t over 4, and that's going to be 16 multiplied by negative cosine of t over 4. You can check if we took the derivative of this, it would work out. We would have negative sine of t over 4, because there's a negative in front, and the derivative of cosine gives us a negative sine. So we would get positive sine of t over 4 because of the two negatives. We'd also get 1 over 4 from the chain rule getting multiplied by 16, and 16 times 1/4 gives us that factor of 4 that we want, and so this is correct. Just throw on an arbitrary constant. We might as well also let these two negatives cancel out, so this will just be plus, and now it's a little bit nicer. And that is our final answer for part D. And that completes our solution to free response question 5 from the 2024 AP Calc BC exam. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. If you want a little bit more practice, check out my 10 hours of AP Calc ABBC FRQs video linked in the description as well. Thanks for watching.
I'm the mathematical menace, the machinations of mankind. Two calculators at the same time, hand signs and abacus, finger count and calculus. I'm a V to the T, my parameter the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me to Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponents know they need